So for our final example for graphing a quadratic inequality, we're going to do it from start to finish, all right? So we need to create the graph, then we need to decide on solid line, dash line, and then do our shading. Okay, so the first thing I need is the vertex. So I'm going to start with x equals negative b over 2a, negative 12, over 2a, 2 times 2. So double negative is a positive. So we get our line of symmetry is at x equals 3. All right. Then to get our y value out of that, I'm going to pretend it's just an equal to. Don't worry about the inequality sign. That will just impact the graph. It is not going to impact any of our computations. All right, so plug in x equals 3. Let's see. Do the 3 squared first is 9. 9 times 2 is 18. Minus 36 minus 14. This comes out to negative 32. So our vertex is the point 3, negative 32. Now that's a pretty big y value for the vertex. So I'm going to want to scale my graph so it's relatively easy to plot that point. Okay. Now I want to find the x-intercepts if it's factorable. So let's see if we can factor this. 2x squared minus 12x minus 14. I notice all of that is divisible by 2, so if I divide out the 2, I get x squared minus 6x minus 7, and that does in fact factor. So I'm going to go forward with the x-intercepts here. This is x minus 7 and x plus 1, because negative 7 times 1 is negative 7. Negative 7 plus 1 is negative 6. So that's going to give me x-intercepts at positive 7 and negative 1. All right, so if you think of it like a table, like our XY tables, and again, you don't have to do the x-intercepts, but a lot of the problems we're looking at are easy to factor, and it'll give us a really good picture if we have these extra wide parabolas. Okay, so now I'm going to have 7 and negative 1. Y values are 0. Okay, and it's always easy to plot the zeros because it's right on the x-axis. All right. Now I want to make a picture. I'm going to do mostly quadrant 4 because I don't have many negative numbers for x. I'm going to go negative 1, 1, 2, 3, 4, 5, 6, almost 7, 7, negative 1. All right, and then the other x value is going to be 3. Now I need to pick a scale so that I can get to 32, so I'm going to go 5, 10, 15, 20, 25, 30, 35. Okay, here we go. My line of symmetry is here at the negative 3. And I need to have my vertex at negative 32, which is approximately down here. X-intercept at negative 1, x-intercept at positive 7. All right, now go back and look at this. This is y is greater than or equal to the parabola. So the equal to means solid line. So I'm going to try to draw a solid line parabola that goes through all this. I need to start over. Easier said than done. I do much better when I start at the vertex itself. There we go. So solid line parabola. And then y is greater than or equal to. Greater than means go above. So I want to shade above. Let's make this shade faster. So I want to shade from my vertex up. So in this case, it happens to be everything inside the parabola. And remember, I could pick a point from that shaded area and plug it into the inequality to make sure that it actually works. Like I could plug in 3, 0, and it should give me a true statement. All right. Now that's everything you need to know for graphing quadratic inequalities. In part 2 of this lesson, we'll take a look at solving them. All right. Let me know what questions you have.